Hello, welcome to Unit 10, Day 4. Today we're going to be looking at asymptotes and holes for rational functions. Asymptotes we've already talked about, so that'll be a continuation of what we've looked at the past few videos. Holes is going to be something new, but it's building off of what we talked about in our last lesson. So the first thing that I'm going to do is look at number 4. So notice that number 4 has already been factored for us, which is nice. If we had a function that was not in factored form, then we would have to factor it first so that we could try to simplify the fraction as much as possible. So what we'll notice is that the x minus 3 is in both the numerator and the denominator. And so in our last lesson, we talked about factors matching in the top and bottom of the fraction, canceling each other out, because we're essentially dividing something by itself. What we didn't talk about is that when the factors are canceled, they create holes in our function. So the x minus 3 is going to create a hole. Whatever's left over is going to create our vertical asymptote. Also remember that the value that creates our vertical asymptote is not what's in the factor, but rather what brings that factor to 0. So if I see x plus 1 in the denominator of my fraction, I know that a negative 1 will be my vertical asymptote. For the holes, whatever factor I scratch out creates the hole, and the value of x that I use is what brings that factor to 0. So if I see an x minus 3 that cancels out, I'm going to leave a hole at x equals 3. All right, so now we're going to look at how to find horizontal asymptotes. So the thing that I want to remember for horizontal asymptotes is that I'm looking for the highest exponent. You can remember that because they both start with h. All right, so when I look at the example number 1, I notice that the highest power of x is the x squared. So what I'm going to do is isolate the x squared in the numerator and denominator. And then I'm just going to simplify that isolated fraction. So if I take 4 divided by 2, simplifies to 2. So my horizontal asymptote occurs when y equals 2. When I scroll down to number 2, I notice that there's only one x in the fraction. But in order to find the horizontal asymptote, I need to compare both the numerator and the denominator. So what I'm going to do is remember that if I don't see an x, there are 0 x's in the numerator. The other thing that I'm going to remember is that if they don't put a number in front of my x, I can imagine that there is a 1 where the coefficient should be. So when I isolate that fraction, right? 0 over 1 is equal to 0. So my horizontal asymptote is at y equals 0. Finally, when I scroll down to number 4, I notice that x cubed is the highest power. Once again, I do not see an x cubed in the other part of the fraction. So I'm going to pretend that I see a 0 x cubed. And I'm going to fill in the 1 that's missing in front of the x cubed in the numerator. So when I isolate this fraction, I get 1 over 0. And if we think back to what we've said the past few lessons, 0 cannot go on the bottom of the fraction. So because I have an undefined value, there is no horizontal asymptote. So let's look at one more example that kind of puts all of this together. So for this example, I'm going to simplify the expression, and then I'm going to write down the holes, the asymptotes, and then the restrictions to the domain and range. And so we'll notice that a lot of this stuff goes together. But before we do anything, we need to see our fraction in factored form. So if I factor x squared plus 6x plus 9, it splits into x plus 3 and x plus 3. Because 3 times 3 equals 9, and 3x plus 3x equals 6x. The x squared minus 9 will factor into x plus 3 times x minus 3, because positive and negative 3 multiply to negative 9, and 3x and negative 3x cancel out, which matches with the missing value in the middle of the fraction. All right, so the next thing that we're going to do is simplify. So if I see a factor that matches from the numerator and denominator, I'm going to scratch it out and remind myself that that's my whole. And then whatever's left over in the denominator is going to be my vertical asymptote. And then finally, I'm going to isolate my highest powers of x to get my horizontal asymptote. So when I fill it in, my holes bring the canceled out factor to 0. So if I see x plus 3, I know negative 3 will bring that to 0. My vertical asymptote brings the remaining factor in the denominator to 0. So if I see an x minus 3, I know I need a positive 3 to bring that to 0. And then we said to find our horizontal asymptote, we're going to reduce our isolated fraction. So if I see 1x on top and 1x on bottom, 1 divided by itself equals 1. So this will be y equals 1. So for the restrictions of the domain, basically I'm going to write down any x values that make my function undefined. And since the holes and vertical asymptotes come from zeros in the denominator, those are going to be the values we're going to use. So I'm going to say x cannot equal 3 and x cannot equal negative 3. And then for the range, I'm going to do the same thing, but I'm going to look at my horizontal asymptote. So y cannot equal 1. That's all we have for today. I'll see you guys next time.